Hi all, good morning. Today we are going to see the topic laws of thermodynamics. So we are going to see only first and second law of thermodynamics. So in first law, what we are going to see? What is the mathematical form of first law of thermodynamics? First law of thermodynamics. The quantity of heat supplied to the system is utilized in two ways. One part of the energy is utilized to do the work done. Another part of the heat energy is to increase the internal energy of the system. The mathematical form of first law of thermodynamics is dq is equal to du plus dw. We are mentioning in the differentiation term because they are all small quantities. dq is quantity of heat supplied to the system. du is change in internal energy of the system, particularly increase in internal energy. dw is work done by the gas. First law of thermodynamics has certain limitations. It does not say anything about the direction of flow of heat. And the second one is, it does not say anything whether the process is spontaneous process or not. Next one is, in actual practice, the heat energy doesn't convert completely into work. See, part of the heat energy is converted as internal energy of the system. So you don't know about the internal energy. What do you mean by internal energy? The internal energy is defined as the energy associated with the random disordered motion of molecules. The internal energy of the system is sum of all the energies, that is mechanical, chemical, potential, kinetic, etc. present in the system. So for better understanding, I can give the example. We can take the common example of a heat engine. In a heat engine, the thermal energy is converted into mechanical energy, and the process also is vice versa. Here I say heat engine. It may be petrol engine, diesel engine, or any steam engines. So all the above engines works on the principle of first law of thermodynamics. Since the first law of thermodynamics fails in certain areas, there is necessity for second law of thermodynamics. What is the definition? It is impossible for a self-acting machine, unaided by external agency, to transfer heat from a body at lower temperature to a body at higher temperature. So it is the essence of Kelvin's and Clausius statement. So we cannot transfer the heat from a body at lower temperature to a body at higher temperature without any help. So to transfer from lower to higher, we need help. That help is called external agency. Here, other words we can see the refrigerator. How the refrigerator works? Unless the compressor is driven by an external source, the refrigerator would be able to operate. Heat pump and refrigerator works on the basis of second law of thermodynamics. All the refrigerators, deep freezers, industrial refrigeration systems, all types of air conditioning systems, heat pumps, etc. work on the basis of second law of thermodynamics. The second law of thermodynamics introduce a new concept, entropy. What do you mean by entropy? Entropy is defined as the quantitative measure of disorder or randomness in a system. The concept comes out of thermodynamics, which deals with the transfer of heat energy within a system. Entropy is defined as a state of disorder or a decline into disorder. An example of entropy is a stock market that is in chaos and that makes no sense and is not predictable. So these are all the examples of first and second law of thermodynamics. So basic concepts of thermodynamics we have seen. Thank you very much.